Good morning, ladies and gentlemen. My name is Winfried Benz. I'm Managing Director of Licon, and I would like to give you some insight to our products and our technology. We are talking about doubling of the production of high precision metal parts, and we would give you additional information regarding the technology details. Well, what you do see here is that are the four main topics we are taking care of. On the left-hand side, you do see one leaf flex double spindle machine, in this case with a pellet changer. These machines are capable to machine different parts in different sizes. On the right-hand side, you see some samples of work pieces made out of aluminum, steel, cast iron, or even magnesium. What you do see here, these are mainly automotive components and mainly light metal components. In order to be able to supply a full turnkey equipment to our customers, we also include all software related components such as CAD, CAM, simulation, vibration analysis in order to reduce chatters of tools, and if required, we are able also to supply the full automation system, including washing, deburring, surface inspection, and pelletizing. That's what you see on the right-hand side. Well, let's have a little bit of closer look on these kind of workpieces. On the left-hand side, you do see some kind of battery cases, which in general do have a lot of holes to be machined. You also can see here a shock damper. The requirement for this workpiece is to clamp it in order not to have clamping faults in the workpiece, which would lead to wrong machining dimensions. On the right-hand side, you do see some cradles, mainly made out of aluminum, sometimes made out of steel. Well, combustion is still an issue, but was never the major field we were working in. On the left-hand side, you do see a cylinder cover head, oil pumps, and what you can see here is on the right-hand side, number 3 is a long arm knuckle. We do have a lot of experience in machining these kind of work pieces, even in one clamping 5-axis 5-side machining. Not to forget large and heavy-duty applications such as cases on the right-hand side made out of 3G60. Well, let's go one step further. What is the typical setup which I did see in many of my trips in the North American territory and in Canada? Mainly the job shops and also some other OEMs, they preferred years back the typical one spindle 4-axis machine. You do see here one principal sketch on the left-hand side. The spindle moves in 3 directions, X, Y, and Z. And in front of the spindle, there is one table, we do say a B-axis, which is capable to carry fixtures, mainly tombstone applications, which allow to clamp several parts. Is a big advantage having several parts being clamped, because then idle time is related to the machining time is much more improved, because you change the tool once and you are able to machine 4 of these parts, or in this case 12, 8, 12 or 16. Besides having several workpieces being clamped in the tombstone, it's also possible to have in the tombstone 2 clampings OP10 and OP20 incorporated. That's what we show here in the picture on the lower side. On the right hand side, we do give you some indication what if these workpieces need to having machined compound angles in a 4-axis application. In a 4-axis application, you always need angle heads. And using angle heads, well, we also use angle heads, but if we are able to leave them away, we prefer this one. Because angle heads and in a wet machining surrounding always a bit has always a little bit of difficulty in terms of washing out the bearings, so lifetime is reduced. What is our answer to this? Our answer is at least double spindle machines. What can you see here? These are 2 spindles. We are looking into the machining area. There is a trunnion, and on the left-hand side, the bow, the arrow, shows the A-axis turning, which typically moves 270 degrees. On this trunnion, there are B-axes, which also allow rotation of 360 degrees. The spindles, in this case, are in a so-called Licon I3 configuration. That means you do see 3 arrows for each of the spindle, which shall give you the information that both spindles can be offset individually in all 3 directions. In other words, what you can see here is we do have 2 individual single spindle machines in one housing. That's the Licon I3 philosophy regarding machining of high precision parts. What is the advantage? Related and compared to a 1 spindle machine, a 2 spindle machine only requires 1.2 times of floor space, just 20% more. We don't need to increase labor because 1 machine is 1 machine. The invest is not double, but it's only 60% more. And something similar regarding to the energy, which is only 30% more, but we do have double of the output. In general, Licon is more focused on machining high precision parts. That means if we are able to have complete machining in 1 clamping, it's a big advantage in terms of process stability 24/7. We don't need any angular heads. We don't need additional setups, and the reclamping error is 0, as already mentioned. But it requires 5-axis, 5-side access in general. Well, doubling production output of high precision parts with I3 means, and now we are starting a video which shall show you the independent. You can see the movement of both spindles independently, and you can see that the offset possibility is in Z, in X, and in Y. In Y, in Z, and in X. That's what the video shall show. The spindles are available in HSK 63 and HSK 100 up to torque levels of 500 Newton meters and 16 and 18,000 RPMs. As already mentioned, dual spindle approaches can increase efficiency by 100%, reduce footprint in the shop floor, save cost for energy. Again, the independence of spindles in Z is always given for all Licon leaflex double spindle machines. In this case, you can see our I technology. The combined X and Y error in between the 2 spindles shall indicate that in this case, Both spindles are linked together in X and Y, but not linked together in Z. So why do we need I3? Why is I3 so important if we are talking about high precision parts? What about the rotation error? Let's have a little bit more insight into the technical details of a trunnion machine. What you can see here is that's natural. The trunnion loaded in this case with 4 B-axes and 4 fixtures has a is bending due to gravity, which causes in both in a 0-degree rotation and in 180 degrees rotation position, these kind of bending. And it's self-explaining here that in both cases, an adjustment in X and in Y is necessary to meet high precision tolerances. We can avoid quality issues, and with the I3, we can provide test setups if we change over from one mill piece to another, because runoff is very simple being done. Let's see and let's explain what we are talking about here. That's the view on the machine. Up you see in green the 2 spindles, and you see the 2 workpiece rotation diameters related to B-axis and 0-degree BX position. If BX position is rotated by 180 degrees, the datum D1 rotates to the other direction on the left-hand side. For example, if you are doing this setup and with a cold machine, there's a difference to when the machine is in operating temperature, because we do have a natural growth in X, because we are talking about metal and temperature increase. The thermal growth, which you see here, will end up in a dislocated datum on the lower side in 180 degrees rotation position. And in this case, we are talking about errors, which you can see here. To avoid any kind of these errors, therefore, we need to adjust in X and sometimes also in Y. That's why for high precision machining with double spindle machines, you should use I3. That's just one of the reasons. Here is another overview of the constraints for rotation error with twin spindles. Either if you're using ball screws or linear drives, the thermal growth is always given in the machine as long as this machine is made out of steel, which is certainly the case for 99% of all the machines. The environmental situation in the facilities sometimes do have a very heavy impact on the thermal growth, because not seldomly temperatures variate more than 10 to 20 degrees during the day. We also are able to adjust our CMM output of all the datums just related to both of the individual spindles, in order that the operator can easily offset if required. With the independent Z-axis, there is no need to have very well, let's say, identical dimensions of the tools, because both spindles can be independently moved. Sorry. Okay. Also mentioning to the i3, we only need one NC program for both spindles, but they do allow individual offsetting. And again, the simplicity is obvious if we have two one spindle machines in one housing. i3 ideally combines the advantages of single spindle machines with the performance of a twin spindle. That's just a view into a machine. The weight here of this workpiece is above 100 pounds per workpiece, and we are able to machine these 3G60 parts with stock removals up to 8 millimeters, which is a third of an inch. Here is another reason. If you need to have a circular milling process in the machine, and in case you do have different diameters available in tooling, the tool path needs to be different in order to achieve the same machining results. Here, that's just one example. 7 microns offset in X and Y to produce the same diameter on both spindles under these preconditions, which are shown here. Looking on other applications, such as cases for e-motors, we do see some very tight tolerances which needs to be machined in order to fulfill the requirements of these housings for e-cars. We are talking about datums which are less than 50 microns, and we need to achieve these ones, including the rotation error. Currently, we are just doing a runoff, and I brought with me one of these examples, and the feature 63 shows you on a datum requirement of 50 microns, shows you capabilities, CPK capabilities better than 3. We only can achieve that if we can offset both spindles independently. Let's have a quick view on our product philosophy. Our product is in a high standard and is able to be combined with different loading options, such as a pallet changer configuration on the left-hand side, allows you quick changeover from one workpiece to another within half an hour. If the machining cycle is relatively long, there is no need to have a second set of fixtures available in front of the machine, which most of the time is sitting there and waiting for being turned into the machining area. So therefore, this is our definition of direct loading. Very often for these kind of applications, these machines are combined with a robot loading. On the right-hand side, this is our double trunnion application, which also has sometimes huge advantages because changeover is less than 6 seconds from one trunnion to the other one. In a total overview, we show you here one spindle application possibilities and two spindle application possibilities or configuration possibilities on the right-hand side. All the machines are available for 4-axis machine as well as for 5-axis machines. Spindle distances can vary starting from 400 versus 450, 750 millimeters, 1050 millimeters, 1200 millimeters, and we also added a 4-spindle application, which is on the right column. That's just an insight of different fixtures. As I already mentioned, we are supplying not only the machines, but also the fixtures, the tools, the programs. And we are emphasizing that our fixtures are always designed in order that we use deep hole drilling channels to avoid tubes around the fixture body, which always would cause some chip nests. And in this case, the fixtures, for confidentiality reasons, we cannot show the related workpieces, but I guess you can imagine that on the upper picture, these fixtures allow to clamp two long arm knuckles in one fixture, and both long arm knuckles are machined completely in one clamping. On the lower picture, this is a typical 4-axis trunnion for machining different parts in a double threaded machine. As already mentioned in the beginning of this presentation, I mentioned that our scope of supply also includes all the nowadays digital requirements in terms of machining simulation, but also in terms of vibration diagnostics. All our Licon spindles do have vibration analysis possibilities, and with our expert knowledge, we are able also to support our customers in order to reduce vibrations. You see these signals before and afterwards. The more we reduce the vibrations, the better the lifetime of the tools. These are completely related. These graphics are completely related to dollars. The lower the vibration, the lower the tool cost. In addition to this, we also are able to supply complete lines, as you can see here. This is a line, meanwhile, 5 machining double spindle centers in this line. This line is linked by one robot on a 7-axis, and the line is able to run without operators more than 2 hours. Included in this process is deburring, it's cleaning, surface inspection, CMM measuring, and completely reloading of these conveyors, as you can see here. Well, that was the overview of Licon, of leaflex double spindle machines using i3 technology for high precision parts. Licon is located in the south of Germany, and here in this facility we are producing our machines and we are serving our customers worldwide, in the US out of Dexter, Michigan, and in China out of Beijing. We are a little bit more than 200 people, and with a heavy with a lot of technology impact on what we are doing day by day. Thank you very much.
So thank you, Mr. Betz. Now is the question part. So if you have any questions, just let us know. We'll double check which questions already came in. So here is the first one. For which cubic sizes is the i3 technology available?
Well, we are starting with i3 beginning on a spindle distance of 750 millimeters, 1050 millimeter, 1200, and we are even going higher up to 1500 spindle distance. The larger the spindle distance, the more necessary is using i3, because the thermal growth in absolute figures is larger, the larger the spindle distance is.
Okay, thank you. So the second question there is, are there any disadvantages regarding feeds and speeds with i3 technology?
Well, no at all. We also supply these i3 technology with linear driven machines, and there is no restriction on this.
Okay, and we have a last question. In which parts do you see the biggest need for such a technology?
Oh, that's a good question. Well, in general, I would say the more precise the requirements are, the more need of i3 technology. Currently, we are talking a lot of e-mobility, and as already shown here, we do see many high tolerance requirements or tight tolerance requirements for motor housings, but also for steering tubes sometimes, and many other parts. I would say datums less than 40-50 microns and needed to be on 180 degrees rotating require i3 in order to have a robust process available.
Okay, so I'm checking, but I cannot see more questions here in our control thing. So are there any more questions?
Obviously not. Well,
I don't see more.
Okay. Okay, so thank you very much. I think we are done. I appreciate very much your attention, and please don't hesitate to contact us for any kind of questions. Thank you very much.